A new race in military technology is unfolding as China tests its hypersonic cargo drones, leaving US analysts shocked. China has spent many years improving its missile and aircraft technology, and recent reports indicate that the country is moving rapidly toward hypersonic flight. This would mean aircraft travel at speeds above Mach 5, moving at least 5 times faster than the speed of sound. At those speeds, thousands of kilometers are covered in a very short time, also making interception extremely difficult. Military analysts in the US follow these developments closely because hypersonic systems could change how future wars are fought. To understand why this matters, it helps to start with the basic idea behind these systems. One of the most discussed projects is a high-speed unmanned aircraft called the MD-22. This aircraft operates without a pilot and is designed to fly at up to Mach 7. That speed equals about 8,600 kilometers per hour. Engineers designed the MD-22 as a reusable vehicle so it can complete a mission and return for another flight. That feature reduces cost and allows frequent testing and training. The range of the MD-22 also stands out. Reports suggest the aircraft can travel close to 8,000 kilometers during a mission. That distance allows the aircraft to operate across very large regions without relying on nearby bases. Long range becomes important when countries plan for operations across oceans or distant areas. High speed creates many advantages in military planning. A missile or aircraft that travels slowly gives defense systems time to detect it, track it, and launch interceptors, whereas hypersonics shorten that instantly. Radar systems must detect the object and calculate its path in seconds, and that challenge becomes harder when the vehicle also changes direction during flight. Many hypersonic designs include maneuvering capabilities that allow them to adjust their path while moving at extreme speed. Another innovative way Chinese researchers did is to experiment with new ways to launch these aircraft. Traditional missile launches often take place from ground silos, aircraft, or naval ships. Recent tests showed a different method that uses high-altitude balloons in near space. Engineers attach a hypersonic test craft to a balloon that rises to the upper atmosphere. Once the balloon reaches a high altitude, it separates and begins its powered flight. The advantage of high-altitude launches also creates flexibility for deployment. A balloon can travel long distances with the wind before releasing its payload, and that movement makes the launch location harder to predict. Military planners study this method because it could allow launches from unexpected positions. Defense systems that rely on fixed monitoring zones would need adjustments if launch points move across wide areas. Analysts often describe these experiments as a sign that engineers search for creative solutions that extend the reach of hypersonic technology. Naval warfare is another important part of this discussion because these new high-speed weapons could directly affect how navies operate. Aircraft carriers play a central role in the US military strategy because they carry fighter jets and support operations across the world. However, extremely fast anti-ship weapons could challenge those defenses because their speed reduces the time available to detect and intercept them. China has already tested advanced anti-ship missiles, and many analysts believe these systems are designed specifically to threaten aircraft carriers. One example is the YJ-20 anti-ship missile. Reports indicate that China tested this missile from modern naval bases called Type 045 destroyers. These ships serve as some of the most advanced surface fighters in the Chinese Navy. They carry powerful radar systems, large missile launch cells, and advanced electronics. Launching a hypersonic anti-ship missile from a ship creates a mobile strike platform that can operate far from land bases. A missile fired from the ocean can approach a target from different directions, and that increases the complexity of defense planning. A carrier strike group relies on several layers of protection to defend against incoming threats. These defenses include early warning aircraft, long-range radar systems, and interceptor missiles that work together to detect danger as early as possible. Each layer attempts to detect threats earlier, so defenders gain more time to respond. Hypersonic weapons compress that timeline because the incoming object moves extremely fast. Defense teams must track the missile, confirm its path, and launch countermeasures very quickly. Every second becomes important during such an engagement. Military researchers in the United States and other countries continue to develop new sensors and interceptors to address this challenge. Another area that draws attention involves the cost of hypersonic systems. Early hypersonic weapons required very advanced materials and expensive engines. Those requirements limited how many weapons a country could produce. Recent reports from early 2026 suggests that Chinese engineers are working on designs that reduce cost while maintaining high speed and maneuverability. One reported system carries the name YKJ-1000. Analysts describe it as a hypersonic glide missile designed for large-scale production. A hypersonic glide missile works differently from a traditional ballistic missile. A ballistic missile launches high into the atmosphere and then follows a predictable arc back toward the target. A glide vehicle separates from the rocket and then travels through the upper atmosphere while gliding toward its destination. During that glide phase, the vehicle can adjust its direction and altitude. That moment creates uncertainty for radar systems because the path changes throughout the flight. Affordability could influence military strategy because a lower cost allows a country to build larger numbers of weapons. Each interceptor missile also carries a high cost, so defenders must balance resources during conflicts. Analysts often describe this situation as a competition between offense and defense technology. China invests heavily in research laboratories and aerospace programs to support these developments. Universities, state research institutions, and defense companies collaborate on materials science, propulsion systems, and aerodynamic design. Hypersonic flight places extreme stress on any aircraft because friction with the atmosphere generates intense heat. Engineers must develop heat-resistant materials that protect internal components during flight. Specialized coatings and alloys help maintain structural strength at very high temperatures. Guidance systems also require advanced engineering. A hypersonic vehicle travels so fast that small navigation errors can grow into large deviations over long distances. Engineers design sensors and onboard computers that calculate the vehicle's position and adjust the flight path continuously. Satellite navigation systems, inertial measurement units, and radar guidance technologies work together to keep the vehicle on course. The United States also conducts its own hypersonic research programs. American defense agencies test new missiles and glide vehicles while improving detection systems that track high-speed threats. Satellite networks, advanced radar installations, and new interceptor concepts form part of that effort. Military planners emphasize the importance of maintaining technological balance so that defense systems keep pace with emerging weapons. Strategic analysts often describe hypersonic systems as a new phase in the evolution of missile technology. Earlier generations of weapons relied mainly on speed or range, while modern designs combine speed with maneuverability and precision guidance. Those features make the systems more flexible and harder to defend against. China's recent tests and development programs therefore attract attention across the defense community. Analysts examine each report carefully because every successful test provides clues about technological progress. Government agencies, research groups, and defense companies all evaluate the potential impact of these systems on future conflicts. The discussion extends beyond weapons alone because logistics, training, and command systems must adapt to operate alongside hypersonic platforms. Public reports rarely include full technical details about these programs, so analysts often rely on satellite imagery, official announcements, and scientific publications to understand what progress is being made. By studying these different sources, researchers slowly piece together a clearer picture of how these systems work and how capable they might be. That process requires careful analysis because military projects often remain classified or partially hidden. This limited information also explains why experts continue to watch new developments very closely. Many observers believe the next decade will bring further breakthroughs in high-speed flight. Engineers continue to refine propulsion systems, improve navigation accuracy, and reduce production costs. Those improvements could expand the role of hypersonic platforms in surveillance, strike missions, and rapid response operations. Defense planners around the world follow these changes closely because the technology could reshape military strategy.